In this video, we're going to talk about isomers and go through the process of determining the number of isomers for a given compound. So to start, we're going to define structural and stereoisomer, as those are two terms that you'll see in your work. So a structural isomer, these are two compounds with the same molecular formula but different structural formula. So what this means is that the atoms are arranged in different ways within the molecule. So as an example, if we have the compound C4H8, so butene, we can draw this in a couple of different ways. So we can draw this as but1ene, but2ene. There's more than just three, but I'll just draw three for now, or cyclobutane. So in all three of these examples, the formula C4H8 stands, but our compounds have very different structures. For a stereoisomer, we have two compounds with the same molecular and structural formula, but they have different arrangement of their atoms in 3 space. So we'll look at what that actually means. And I'll keep using C4H8 as my example, and I'm going to take but2ene, and I'm going to show that we can draw this in 2 different ways. So we can draw it as I've drawn it there, with our double bond in the middle. We can also draw this structure this way. The top structure is called trans but2ene, and the bottom structure is called cis but2ene. And the reason that these structures are technically different has to do with this double bond in the middle. So double bonds are inflexible, so atoms can't freely rotate around them. If the atoms can't rotate, that means that the arrangement of the carbon atoms attached to that bond, so I'm just putting stars on them here, they're stuck in space. They can't move, so it's not possible to go between these two structures. So they're inherently different. Trans means that the groups are pointing in opposite directions off of that double bond. Cis means they're pointing in the same direction. We're going to be focusing almost exclusively on structural isomers for the rest of this course, though. So one thing we need to look at when we're talking about isomers is the units of unsaturation. And a unit of unsaturation is how many hydrogens the compound differs from an alkane with the same number of carbons. So our alkane formula is CnH2n plus 2. Every time we remove 2 hydrogens, that's equivalent to 1 unit of unsaturation. It doesn't mean that the compound is unsaturated. It means that it just has a different number of hydrogens than the alkane would. 1 unit of unsaturation is either going to be a double bond or a ring. Now if we remove 4 hydrogens, that would be 2 units of unsaturation. And this could have the feature of a triple bond, 2 double bonds, a double bond plus a ring, or two rings. So as we remove more hydrogens, it gets more complex, the types of isomers that we can form. So we're going to look at an example and go through using this unit of unsaturation to determine what isomers are possible. We're going to use C5H10 as our example. So C5H10 has the general formula CnH2n. That means that it has one unit of unsaturation. So it either, the formula is, or the structure is going to have a double bond or a ring. We will have no alkanes among our structures. So I'm going to start by drawing all of my straight chain alkenes, and then I'll do my rings. So I'm going to start by drawing a 5-carbon chain, and I'll just stick that double bond on the first carbon. It's a good idea to name your isomers as you're drawing them to make sure you don't double up by accident. So I have pent-1-ene, and then I have pent-2-ene. That's all of these straight chain isomers for 5 carbons, because if I were to stick my double bond on the third carbon, it still is pent-2-ene. Now I'm going to remove one of my carbons from the chain, so I'm going to make my parent chain 4 carbons, and I'm going to make that removed carbon a group. Once again, I'm just going to throw a double bond in at the beginning. So this is going to be 2-methyl but-1-ene. And then I can move that methyl group down, and I get 3-methyl but-1-ene. And then I can move my double bond into the middle, and I will get 2-methyl but-2-ene. Okay, so I've drawn all of those. It's not actually possible to draw a 3-member chain because of that double bond. You can try, and you will see that you will be unsuccessful. So now we're going to look at our rings. So I'm going to start by drawing a 5-membered ring. Simplest ring I can draw, and that's going to be, cyclopentane. Now I'm going to make it a slightly smaller ring, so 4, and that requires me to have a methyl group. That's going to be methyl cyclobutane. Now I'm going to make that one smaller, start with cyclopropane, and I'll make an ethyl off of that, ethyl cyclopropane. And now I'll make that ethyl into 2 different methyl groups. So this can be 1,1 dimethyl cyclopropane. So the reason we need the numbers now is because we have 2 functional groups within our compound, and so we need to identify where they are relative to each other. And then lastly, we can have 1,2 dimethyl cyclopropane. So we have in total 10 isomers for this compound. As you keep practicing, the more carbons you have, the more isomers you'll have. And the more units of unsaturation, the more combinations you can have.